Hello students, welcome back. This video is part 8 on motion in a plane. First question. In a harbor, wind is blowing at the speed of 72 kilometers per hour and the flag on the mast of the boat anchored in the harbor flutters along northeast direction. So what is the direction of flag? Northeast direction. If the boat starts moving at a speed of 51 kilometers per hour to the north, okay, so boat is going to move towards north direction. What is the direction of the flag on the mast of the boat? So what is the direction of flag? This you have to find out. You have to find out the direction of the flag. Now, so we have to calculate relative velocity of the wind with respect to boat. So what is the formula? VW, relative velocity of the wind minus relative velocity of the boat. Okay, so wind speed is given in the question 72 km per hour and velocity of the boat is 51 kilometers per hour. It is given. So subtract, you can calculate the relative velocity, magnitude of the relative velocity you can find out. Okay, but it is not the question. Actually, you have to find out the direction of the flag. Okay, so no need to calculate the magnitude here. So directly we will go to the direction. So direction, what is the formula? I told you relative velocity case 3. Okay, so tan beta is equal to VB sin theta divided by VA plus VB cos theta. Do you remember this formula? Okay. So VB sin theta divided by VA plus VB cos theta. So this formula we are going to use to calculate the direction of the flag. Okay. So VB, so here is nothing but the velocity of the boat. Okay. So 51 kilometer per hour. So 51. And what is the angle between it is given in the question that the flag is moving towards north. The flag flutters along northeast direction. It is given. So the angle between the east direction and the northeast direction is 45 degree. So 180 minus 45 is 135. So this will be the angle between the flag and the boat. Okay, so I'm substituting theta value as 135 here. So 51 sin 135 divided by 72 plus 51 cos 135. So sin 135 is nothing but sin 45. Cos 135 is nothing but minus cos 45. Okay, by using trigonometry relationship. And what is sin 45? 1 by root 2, isn't it? So 51 into 1 by root 2 divided by 72 minus 51 into 1 by root 2. So the value will be 1.0039. So this value is nothing but tan beta. So what is beta? So beta is nothing but tan inverse of 1.0039. So by using trigonometry table, you will find beta equal to 45.1 degree. Okay, so northeast direction will be 45 degree as per the question, but we got 45.1 degree. So you have to subtract both the values. 45.1 degree minus 45 degree, you will get 0.1 degree. So it means the flag will flutter almost in east direction. Approximately it will flutter along east direction. Next question. The ceiling of a long hall is 25 meters high. What is the maximum horizontal distance that a ball thrown with the speed of 40 meters per second can go without hitting the ceiling of the hall? So what is given, students? Maximum height of the hall is given 25 meters. And the speed of the ball is given 40 meters per second. So what is your question? Maximum horizontal distance. Okay. So R is your question. Okay. Do you remember in part 5 video we have discussed about the projectile motion. Okay. There we derived many expressions and this is one among them. To find the maximum horizontal distance R. Do you remember this graph, students? Okay. So this is the maximum horizontal distance. So they are asking you to find what is the horizontal distance. Okay, fine. So what is the formula to find our maximum horizontal distance? U squared sine 2 theta. So formula is here. U squared sine 2 theta divided by G. Okay, R is unknown. U is given. Yes, it is given. 40 meters per second. G is gravitational acceleration. You know the value, constant value very well. 9.8 meters per second, meter per second squared. Okay, so this value is also known. U is known, but theta you doesn't know. What is theta? You doesn't know, right? So for that, we need to find out the theta first. So use this formula, height formula, maximum height formula. What is it? U squared sine squared theta by 2g. Okay, so by using this formula, you can find out what is theta first. Fine. So let us start this. So H max equal to U square sine square theta divided by 2g. So sine square theta equal to, so what is the maximum height? 25. So cross multiply this, students. H max into 2g divided by U square. Okay. So sine square theta equal to 25 into 2 into 9.8 divided by U square. 40 square. 40 into 40. So the value will be 0.30625. So this is nothing but sine square theta. So take sine theta. What is sine theta? Take a square root. So 0.5534 will be. So theta is equal to sine inverse of 0.5534. So theta will be 33.6 degrees. Now you can find out what is R, maximum horizontal distance. So substitute theta value as 33.6 degrees. Okay. So sine 2 theta. So 2 into 33.6 degree is nothing but 67.2 degrees. Okay. So 40 into 40 sine 67.2 degrees divided by 9.8. So what is the maximum horizontal distance? 150.5 meters. Next question. A cricketer can throw a ball to the maximum horizontal distance of 100 meters. How much high above the ground can cricketer throw the same ball? So what is given, students? Maximum horizontal range is given. Okay. That is R max. R max is given as 100 meters. So what is the formula for maximum horizontal range? U squared by 2g, isn't it? So 100 is equal to U squared by g. So let me take this equation as number 1. So what is your task? How much high above the ground can cricketer throw the same ball? So height is your question. Maximum height is your question. So what is your formula, students? Height equal to U squared sine theta divided by 2g. Now what is your theta here? Read the question again. How much high above the ground can cricketer throw the same ball? So here the angle will be, the angle of projection is 90 degree because he is throwing the ball vertically upwards above the ground level. Okay. So here theta will be 90 degree. Okay. So shall we substitute the values? H equal to U squared sine 90 divided by 2g. So let me take this equation as number 2. Now compare your equation 1 and 2. Compare equation 1, 2. So first equation is u squared by g. Second equation is, so what is sine 90, students? Sine 90 is 1. So u squared by 2g you got in second equation. So while comparing equation number 1 and 2, you will get h max. Okay. So maximum height in vertical direction, h max is equal to r max, maximum horizontal range, divided by 2. Okay. So what is maximum horizontal range? 100 meters. As per your question, 100 meters. So divided by 2 equal to 50 meters. So this is your maximum vertical height. Okay. Vertical distance a cricketer can throw the same ball. 50 meters is your answer. Next question. A stone tied to the end of the string 80 centimeter long is whirled in the horizontal circle with the constant speed. If the stone makes 14 revolutions in 25 seconds, what is the magnitude and direction of acceleration of the stone? So what is given, students? The length of the string. So here length of the string is nothing but the radius of the circle. Okay. So 80 centimeters is nothing but 0.8 meters. And V is given 14 divided by 25. That is 14 revolution per second. So V is given. And omega. What is omega? Angular velocity. Okay. So 2 pi V. So 2 into 22 by 7 into, in place of V, we have to substitute 14 divided by 25. Okay. So what is omega? 88 divided by 25. Then your question is, what is the magnitude and direction of acceleration? So acceleration is nothing but centripetal acceleration. Okay. So centripetal acceleration is nothing but omega squared r. So 88 divided by 25, the whole squared into r is 0.80. So what is the answer? 9.90 meters per second squared. Then the direction of centripetal acceleration is along the string directed towards the center of circular path. So it is centripetal acceleration always. So there will be a force towards the center of the circular path. Next question is, an aircraft executes a horizontal loop of radius 1 kilometer with a steady speed of 900 kilometers per hour. Compare its centripetal acceleration with the acceleration due to gravity. Okay. So what is given, students? Radius is given 1 kilometer or 10 to the power 3 meters. And speed, okay, so 900 kilometers per hour. So convert into meter per second, 900 into 5 by 18 equal to 250 meters per second. Fine. And what is your centripetal acceleration? AC equal to, see actually students, we have two formula for centripetal acceleration. Centripetal acceleration AC is equal to omega squared r. This is one formula, or V squared by r. So according to your given value, you must choose your formula. Here we have velocity. So I'm going with the second formula, V squared by r. So 250 the whole square divided by r is 10 to the power 3. So what is your centripetal acceleration? 62.5 meter per second squared. Now we need to compare. So that is your question. Compare its centripetal acceleration with the acceleration due to gravity. That is g. Okay. So AC divided by g is equal to 62.5 divided by 9.8. So 6.38 is the ratio between your centripetal acceleration and acceleration due to gravity. Special students, the position of a particle is given by, so position vector is given here, r equal to 3ti minus 2t square j plus 4k meters. So position vector is given ijk format, where t is in seconds and the coefficients have the proper units for r to be in meters. So this is a position, SI unit is meters. R is measured in meters. So find the velocity and the acceleration of the particle. This is your first part of the question. Second part is, what is the magnitude and direction of velocity? Magnitude and direction of velocity of the particle at t equal to 2 seconds. Fine. So first we'll find what is velocity and acceleration for the given position vector. So first you have to write the position vector 3ti minus 2t square j plus 4k meters. So what is the velocity? How you will derive velocity from the position vector? So we know the formula. Instantaneous velocity is nothing but differentiation of position vector with respect to time. Fine. So d by dt of, so what is your position vector? First term is 3t plus d by dt of minus 2t squared, and third term is d by dt of 4. Okay. So differentiate the first term 3t with respect to t. So what is the formula? I'll write. If you differentiate x to the power n, what you will get? Differentiate, see, this is your function, x to the power n is your function. If you differentiate this function with respect to x, what you will get? N into x to the power n minus 1. So this is your formula. Fine. So you have to differentiate now the function 3t with respect to t. Fine. So 3 times of t to the power 1. So nothing is here. So t to the power 1. So t to the power 1 means what? 1 into t to the power 1 minus 1. 1 minus 1. So t to the power 0 is nothing but 1. So 3 into 1, you will get 3. Plus, I'm sorry, this is minus. We have a minus term in between. So minus 2t squared. 2t squared. So t to the power 2. So this is your function minus 2t squared. So what is t squared first of all? 2t to the power 2 minus 1. Okay. So you have 2 multiply 2, you have, so 4t. So minus 4t. And 4 is a constant. So if you differentiate constant with respect to time, you will get 0. So this is your velocity, students. So v of t is equal to 3i. So we have a vectors here, right? So 3i minus 4tj meter per second. So we differentiated the position vector with respect to time. So time as a unit is second. Fine. So this is your velocity vector. And to find acceleration, again you have to differentiate velocity with respect to time. Okay. So dv by dt equal to, first you have to differentiate the first term. So now we will be calculating acceleration. So d by dt of the velocity term, I am writing the first term 3i minus d by dt of 4t. j. Fine. So this is your acceleration. Fine. So first tell me what is 3I. See, this is your constant. 3 is your constant. Okay. So if you differentiate constant with respect to time, you will get 0. And 4t, if you differentiate 4t is your function. So 4t with respect to time, you will get 4. So minus 4j meter per second squared is your acceleration now. Fine. So first subdivision over, we calculated what is velocity and acceleration of a given position vector. Then what is the magnitude and direction of the velocity of the particle at time equal to 2 seconds? So what is the magnitude first of all? Velocity. So now we have to find magnitude and direction of velocity. So velocity will be, magnitude of the velocity will be equal to square root of the component Vx squared plus Vy squared. So this is your formula. Okay. So that is nothing but the resolution. Okay. So velocity vector along x-axis or with unit vector I. Okay. Plus square root of velocity along y-axis. That is j vector. So what is Vx squared? That is along your x-axis. So this is your velocity vector, right? So 3 squared, square root of 3 squared plus within bracket you have 4. Okay, so minus 4. You have a t here. So 4 into t, right? So we need to calculate the magnitude if time period t equal to 2 seconds. So substitute 2 here. 4 into 2. In place of t, we substituted 2 here. Okay. So 3 squared plus 4 into 2, the whole square. The answer will be 8.54 meter per second. See, this is your magnitude. Then what is your direction beta? Beta equal to Vy tan beta equal to Vy divided by Vx. So here Vy is nothing but minus 4t divided by Vx is 3. Substitute t as 2 because we need to calculate magnitude and direction when time is 2. So minus 4 into 2 divided by 3. So tan beta equal to minus 2.667. Then what is beta? Beta equal to tan inverse of minus 2.6667. Then beta will be minus 69.44 degrees. 69.44 degrees from negative x-axis. 69.44 degrees from negative x-axis. So this is your direction of your velocity vector at time equal to 2 seconds. With this video, I have completed chapter 4, motion in a plane. Students, home-based examination portions are physical world, units and measurements, motion in a straight line, motion in a plane. All the very best for your examination. Bye-bye.